Hi, I'm Ehsan Gane and I'm with Michigan State University. In this video, I'm going to talk about denitrifying bioreactors. A denitrifying bioreactor is a conservation drainage practice that primarily targets nitrate loss in subsurface drainage discharge. NRCS has a standard code 605 for this practice. A denitrifying bioreactor is a conservation drainage practice that's installed at the edge of the field, similar to the saturated buffer. It's basically a trench that is filled with wood chips. The wood chips provide the organic matter for the denitrifying bacteria to reduce nitrate to nitrogen gas. So let's look at this diagram here. We have a subsurface drainage farm. Nitrate leaves that farm through the subsurface tile drainage system, and it enters the denitrifying bioreactor. There, nitrate, with the help of the denitrifying bacteria, get converted into nitrogen gas, and the gas leaves the system. And reduced nitrate is the outcome of the system that leads to improved surface water quality. This is another side view of the denitrifying wood chip bioreactor. So when water comes from the field, it enters the first chamber, and from the first chamber it enters the middle chamber, and from there it enters the bioreactor, and the bacteria help convert nitrogen into nitrogen gas, which leaves the system. Similar to the saturated buffer, you can use the three-chamber controlled structure here, like in this case, and you can implement controlled drainage with the first chamber of the saturated buffer to get additional water quality benefits and potential crop yield benefits. This is the top view of that same system of a wood chip bioreactor. So you can see we have a three-chamber control structure, and the first chamber is used as controlled drainage. So when water comes in from the first chamber, it enters the middle chamber, and from there it enters the wood chip bioreactor. So the bypass is in the three-chamber control structure, the last chamber of that. And if the bioreactor can't handle high flows, bypass will allow the water to leave through the bypass system into the drainage ditch. And also, when water is treated at the very end, water will be able to enter the drainage ditch after it's treated. This is a photo of the three-chamber control structure. When water comes from the field, the first chamber allows for controlled drainage, and from there water moves into the middle chamber, and from the middle chamber water is diverted into the bioreactor, where the denitrification occurs and nitrate is removed. The planned water management for this is similar to controlled drainage or drainage water management. And like similar to the saturated buffer, these two sets of stop logs are going to be managed identically. So if you remove the stop logs, you're going to have to remove it for both. That's how it will be managed for the water management plan. Alternative to the wood chips going all the way to the surface is covering it with soil. And even in that case, you can see here that the wood chips are in the grass area of the buffer, and it's on the ground. So in this case, when the time comes that the wood chips lifetime is over and it's decomposed, then the area needs to be excavated and fresh wood chips need to be poured into the bioreactor. Let's talk about some of the requirements for monitoring of the status of the performance of the bioreactor. Over time, the wood chips are going to subside because the wood chips are going to decompose and the bed is going to settle. If you have wood chips all the way to the top, in that case, you can just pour wood chips on the top of the bioreactor to replenish the wood chips. If there is soil on the top, in that case, you're going to have to excavate and add fresh new wood chips to the bioreactor. In terms of design, you can have a private company design it, or you can refer to your local NRCS office for design guidelines.